Hey guys, so I'm going to be going over the homework Good Vibrations section, the Harmonic Scalpel number 1. So the problems in that section pretty much go over the mass spring system, and this specific question states that two harmonic scalpels have equal mass where the first vibrates at a frequency of 20 kilohertz and the second vibrates at a frequency of 50 kilohertz. And consider each scalpel to be replaced by an equivalent mass on a string. By what factor is the equivalent spring constant greater in the second system? So how I approach this problem is I looked at this in the section and I got this period equals 2 pi square root mass over the k constant. And since it's asking by what factor is the equivalent spring constant, I arranged it to set the constant equal to the mass over t over 2 pi squared. And so I know that t, the period, equals 1 over frequency. So I took the two frequencies and I converted them both into periods. So for this one, for the first one, I got 5 times 10 to the negative 5 seconds. And the second one, I got 2 times 10 to the negative 5 seconds. And so for this problem, it's asking by what factor. And it specifically states that the mass is equal for both. So I just picked just a mass, a random mass. I wanted to go for something small, so I chose 0.5 kilograms. And I kept it constant through both of the problems. So for K1, when I solved it, I put the 0.5 as the mass, and then I plugged in the T for the period. And for the K1, I got 7.896 times 10 to the negative 9 newtons over meters. And here's the value I got for K2. And so it's asking for by what factor is the equivalent spring constant greater in the second spring system. So I put the larger value, the K2, which is the second spring system, over K1, and there's the value. So yeah, hope that helps.